Now I have another question regards to the usage of Newton's second law for the kinetics of particle. So over here I have tutorial 7 question 5. The 2 kg collar C is free to slide along the vertical plane along the smooth rod AB, which is routed onto collar A as shown. The collar A is sliding along the vertical shaft with a acceleration of 4 meters per second square upwards. Determine the acceleration of the collar C and the force acting on collar C by the rod AB. Okay, so to do this question, we will draw the free body diagram and a kinetic diagram. Alright, we know that the acceleration 4 meters per second square upwards is in a positive j direction, and that's the acceleration of AA. Okay, and we know that AC is also getting the acceleration of AA because it is along the rod AB, so there will be acceleration of AA. At the same time, rod C is moving along this rod AB, so there will be an acceleration of AC from A constrained in the 45-degree direction. So that's the kinetic diagram. Kinetic diagram meaning to which I will add the mass lah. So, but you get what I mean. Okay. Over here we have the free body diagram. We know there will be a normal force acting onto collar C by this rod AB and the weight of the C of this collar C downwards. Okay, so with that said, we will now do the question. So acceleration of C is acceleration of C from A plus acceleration of A, and we know that acceleration of A is 4 meters per second square in the positive j direction, and we know that acceleration of C from A is constrained within 45 degree. Alright, so we will combine whatever we have. So acceleration of C is acceleration of C from A plus acceleration of A, and we'll have the first equation, and we have two unknowns, and we are unable to solve these two unknowns, and hence we must find more equations to put in. Okay, next we'll do Newton's second law, where force equals mass times acceleration, where I'll take I and J components of this Newton's second law of this collar C. So for the I direction, I have the normal force cosine 135 is equals to mass of collar C, which is 2 kg, multiplied by acceleration of C from A cosine 45 degrees. So that's the I direction. Following which I'll do for the J direction as well lah. So just look at the workings over here. So over here we will realize that we have 3 equations and 3 unknowns, and hence we can solve all 3 unknowns. So from equation 2, we will manipulate such that we will express acceleration of C from A as a term, and then we will sub this into equation 3 over here, because that's acceleration of C from A. So once we put this in, we can easily find what's the value of the normal force, and that's 19.53 newtons, and we know that it is in the 135 degree direction. Okay, next we'll substitute the value of N into equation 4 to find the acceleration of C from A, and we find this out to be negative 9.765 meters per second square. Now that we have AC from A and AC from A, we can easily find acceleration of C by subbing this into equation 1. And very simply, we know that acceleration of C is equals to 7.45 meters per second square in the 157.183 degree direction. So that's all for this question.